Hey, how's it going, everyone? Hope you're all doing well. Welcome back to question number 19 of the 30-day LeetCode challenge. Today's question is called Goat Latin. Not a particularly difficult question, but it's a fun one because Goat Latin's a pretty interesting language. Plain sounds really close. Anyways, so the question says, a sentence S is given, composed of words separated by spaces. Each word consists of lowercase and uppercase letters only. Okay, we want to convert the sentence to Goat Latin, some made-up language similar to Pig Latin, and there's 3 rules. Number 1 is if we encounter a vowel, put an MA. Number 2, if a word begins with a consonant, so anything that's not a vowel, remove the first letter and append it to the end, then add MA. And the third rule is add a letter A to the end of each word per its word index in the sentence. So for example, the first word gets 1 A, the second word gets 2 A's, and so on. If you look at these quick examples here, I speak Goat Latin, turns into I'm a pixma goatma. It's fairly straightforward, so let's jump into the code. All right, so we got our basic setup here. We got our to-go Latin function and the basic test case at the bottom here. So I want to start off by initializing a variable that's going to hold our final string. So let's call it final sentence. And the idea here is we're going to be looping through all of the words that's in our given string. And as we loop through all the words, we're going to apply the rules that were given in the question, turning it into Goat Latin and appending it to our final sentence. So one of the other variables I want to initialize is a string that contains all the vowels so that we can check as we're going through the characters in each word whether the word is a vowel. Or actually, we'll only need to check the first letter of the word because the rule says if a word begins with a vowel, append MA to the end of the word. For example, apple becomes applema. All right, so we'll have A, E, I, O, U and A, E, I, O, U. So we want to handle uppercase and lowercase letters. So to get that list of words, we're going to take the string that was given and call the split function on it. Remember, if we don't specify anything in the brackets here, it's automatically going to split it based on the space character. And then we're going to loop through all the words in our string. So we'll say for I in range 0 to the length of words. I'm purposely looping through the index of the words as opposed to going for word in words because we need the index number so that we know how many A's to add at the end of each word, right? That was the third rule that's specified in the question. First, we need to check if words at I, so if the specific word we're at, the first character is in vowels, all right? So if the first character of the word we're at is in vowels, then we want to append MA to it. So we'll say words at I equals words at I plus MA. And remember, we also need to add a certain number of A's to the end of each word. And that number is going to be I, so the index number of the word, plus 1. Because our I starts at 0, and we have to have at least 1 A. So we're going to say I plus 1. Let's put this in brackets. And we want to make sure we also add a space character at the end of the word as well, because we want to make sure after every word, it still maintains a space character. So here's what we'll do for the consonant case. So if a word begins with a consonant, remove the first letter and append it to the end, then add MA. First of all, let's handle the case where we need to take the first character and put it to the end of the string. So to do this, we're going to access the word, and we're going to split it from the index number 1 all the way to the end. And this is going to make sure that we cut off the first character of the word. And then we want to add the first character to the end of that string. Once we do that, we want to also add MA. And we're pretty much going to repeat this logic up here. We want to take the A and multiply it by the position of the word in the string. And then at the end, we want to add a space character. I just realized these should be final sentence plus equals. I don't know why I did words at I, but we need to say final sentence plus equals. Because remember, we're taking the brand new string, we're looping through all the words, and as we loop through, we turn the word into Goat Latin and append it to the final sentence string. Okay, so once we go through this entire loop, we should have a string that contains every word translated to Goat Latin. So let's return final sentence. So here's the result. So for the, we take the T, put it at the end since it's a consonant, and we add MA plus 1A because the is the first word in the sentence. Same thing we do for quick, except we add 2 A's at the end. Same thing for brown. We put the B at the end of the word, add MA, and then we add 3 A's. So this looks like it works. Let's go ahead and submit this and see what the result is. Okay, so the result is a little tiny bit above average for runtime, and the space complexity is also a little bit above average. All right, I think that's going to be the end of this video. There are definitely other ways that you guys can go about doing this. Again, the solutions that I present are just one way of doing them. If you guys have any suggestions on how I can improve the efficiency of the program in terms of runtime or having a better space complexity, then definitely let me know. I'd love to look into how other people approach problems as well. And if you guys learned anything new or you just enjoyed the process of solving the problem, please feel free to like and subscribe. Thank you so much for watching, and I'll see you in the next one. Bye.